G'day guys. Haven't made any videos for a while. Been so busy. Yeah, doing the usual, doing other people's detectors and not doing mine. Oh dear me. Got a rush of 7,000s to do all of a sudden. So yeah, but I'll tell you what, this one 7,000 came in, which is over there. I'll show you what it's. I was really amazed with what's sitting on it, right? But yeah, I mean, I think it's a 45 and another 7 there waiting. But I'll get this one over here. This is a doozy, which, well, I thought anyway. Hang on. Gonna make room, get things out the way. Here we go. Don't want to knock anything over. Frickin' hell. What a frickin' coil. Right? That's an X coil. And yeah, I stuck a $1 coin to it because someone didn't believe how big that these X coils were made. But I think this is 20-inch. The 20-inch X coil. So it's amazing what's made with these. This is obviously a dongled coil. And yeah, God, no wonder you need the extra stick. I think you'd probably need a crane on that's it up there. God, yeah, heavy. Anyway, I don't know if I could. Yeah, I'll show you a few things. Anyway, I've been doing my own stuff as well, but I'll just have to spin this around so to show you. I hope the resolution's really poor so no one can really work it out. But I don't know if you can see there on the screen. Hopefully the resolution, I'm using the front side camera, so the resolution, well, is it the back camera or the front? Oh God, the bit you look at. Yeah, so that's a part of a metal detector project anyway. You can see there, that's just a microprocessor, ins, outs and everything. So going to be a complex little thing. I could show you some parts that I was just playing around with. Hey, if you want to make your own metal detector, it's not that hard. Yeah, basically you can make a just about a complete metal detector out of one of those, which is a nice little nucleo board. Yeah, you can look it up. Another one, if you make a simple metal detector, you can make it up out of one of these, a little Uno board. It has everything on there. You can make a detector. It will work. It just won't be very refined. It probably won't go very deep. You need external transmit and receive preamplifiers and stuff like that. But like all the timing switching, you can just do on those. I suppose I'll show you. I'll show you one of the projects. I've got to get rid of this thing over here. Jesus Christ. Here we go. Okay. Oh dear me. Okay. I think I had this out once before, but been doing a bit more to the way it's been put in. I had to get back on the bench because I just put everything in a box. In this box, oh, okay, here we go. Well, there's our comms to our computer for our programming. It's going to be a bit of a nightmare picking this up, but I can do it. Because I've got a lot of it was done with clip leads because this is set up as a very low frequency sort of a thing. So here we go. There's our display. and we have a numeric keypad for function. And without ripping the wires off, we have a nice little STM board there, which does every function to run a fairly, I won't say basic, but in the middle metal detector. That'll make a complete metal detector. But you do need some other stuff. You need transmit, you need damping, you need receive, and you don't need any of the timings. But all you need is, I have to lift the whole box up. It's a little adjustment there to running the correct levels into the ADC on the board. So that's that. You have to run a separate bi-level transmit driver. Whoopsie. Which is there. I just made that out of an op amp. I've had a bit of noise, so I stuck a cap on there for filtering. But that's just on the transmit output of this, because it's referenced to negative volts. It's just basically a level converter to run the output. And what I'm using is just as a base, so I don't have to go and build up all the stuff like the transmit driver and the preamp and everything else, and the power supplies. Well, yeah, it definitely needs power supplies done. But if I can go a little bit deeper in the box, and you can all have a laugh, I'll get there. Oh dear me. Okay, you're gonna laugh. You're gonna laugh. Yeah, I'll hold this over here. But yeah, that's what I'm. Oops, let me tipped it out the box. Oh, Jesus Christ. Oh, sugar. Oh dear. Yeah, there we go. In the box, it's an ST2000. I'm using that just as some of the ancillary stuff. You know, basically a noisy power supply, and preamplifier, and basically everything. Well, I've disconnected the integrators. I don't need it because I'm doing everything in digital. But the funny thing is that I was running the stop-start power supply on this, and then what happened is the leg on the 4093 fell off. Had to replace that. Then I was direct connecting into the 40106 for the transmit driver. Bloody truck disappeared. I'll tell you what, when you use these old detectors, be careful, because what's happening is that the lamination, or however they laminated the copper onto the fiberglass board, when the board was made in the factory, before it was even etched, whatever they use as a gluing mechanism, it is basically become unglued. And if you take that white paint off these old boards now, all the tracks will float off. They'll float up and they'll break, and you'll be screwed. So you've got to be very careful with these. I've left the white paint on this one and just scratched the legs to get some contact points. But basically just up into the inverter that then goes on to the inputs to the 4066s. That's where I've stopped. We're not using the 4066s or anything beyond. And I've got a switch in there. You can see a switch in the crystals. That's the switch the crystal in and out, because I'm using, just as a reference, I'm flicking it into its normal operational mode just to do some measurements. And then I flick the switch and it disconnects the crystal, and we're running on the timing out of that little board there. So the little board is doing the timings for the transmit and also the receive windows, all the pulse, subtraction, everything like that. It's all on that little board. So you can make a very nice detector. Also on this one we put automatic ground balance. Oh, I shouldn't say that, should I? But it's got automatic ground balance built in. There's no pots needed anymore. unless you want them. So I'll put this back in because this was just a tester to prove concept and to see if we can do it. And there's no way known we're using that microprocessor on there. We're using a much better one, a bigger one with a lot more protection on it for a start. And we're not using internal ADCs. We're using external ADCs that we're probably going to have to heatsink because they, not that you have to clock them really fast, but it's good having the overall bandwidth, and just leads to lower distortion and yeah, not as many errors in the bit rate. So yeah, I'm not going to give out too much details on that, but yes, good ADCs are very expensive, but if you want something that's going to work with very good signal resolution, I mean, you can. There's many ways to do it, but if you want something that is going to have good resolution, because in the way the ADCs work, if you have a look at most of them out there, unless you crank the reference voltage right down and scale the range, these things, you can go over a target, you get no sound, and it's going to jump up 5 millivolts or something to get a signal. It's ridiculous. So a lot of the detectors out there, 10-bit, 12-bit, and you really got to start looking at least 14-bit, preferably 24-bit. And if you want to go the full hog, go into the 30s. But the price for a good one is very expensive. I was looking at some ADCs and I said, oh, well, these would look great, 4-channel input, good, it's got built-in scaling amplifiers and all sorts of lovely things, and some other manipulation you can do to reduce noise. And what was the price? $1,784. And I said, yeah, it's a bit expensive for one component. But if you want to go all out on the ADCs, you can. Or just go analog and use capacitor and, the resistor and an op amp. The old way of doing it, that's basically the way you do it. Just time it with some of those 4066s and what's used in that. That's pretty archaic nowadays. I'd be using something a lot better. 4053, but that's archaic as well. They're all noisy. They're some of them are really non-linear. There's a lot of resistance variance between outputs, and it throws things out, and then you've got to calibrate for all that. And a lot of the early detectors, there's no calibration. It's thrown together in the way. Pray, hope it works. Oh, maybe that's why there's trim pots on there. So, yeah, we're, I just said, time to pull the finger out and do a detector. Like, I can make a real cheap one. I can make something like, God, think of the cheapest PI on the market. I can make something like that. But I don't think that's where you want to go in the market. I think you want to go elsewhere, a little bit up. So that's why I was looking at very high priced ADCs. But that part of it, I don't have to. I could do the whole thing in analog. But, that sort of, I don't know, it's not really the purpose of it all. So if you want to know how to do it, very easy. There's the maths on the board there. You can have a look at that. That's just a simple one. That is, I have to get round because I don't know if this where this is pointing. Probably you can see there. There we go. If you see that, that's all the maths on basically ground balance, cancel, and getting rid of the earth field as well. And if you can read all that, so yeah, that's a formula for it. There's a couple of little other offsets you used to do on the board with a couple of resistors. Don't need to do that. Just do it in software. So very, very interesting indeed. I could, no, I won't. There, I could show you lots of things, but I'm not going to. I'm not going to. Sorry, I just can't. Yeah. Anyway, apart from that, on the detector front, maybe we'll see something pop up commercially. Maybe not. No, there is there's ways and means. Considering somewhere in a factory, there's a pick and place board loader that does 2 channels, 2 lanes at 60,000 components per hour, which needs to be unwrapped, and a massive big nitrogen filled oven for doing the soldering of the boards, and stencil printers and all sorts of stuff. I mean, it's a whole production line kicking around that if you want to make detectors. And yeah, at the moment, I bought this drill. I bought a couple of drills actually. I bought, might as well. A lot of things have happened since I made a video, but that's just for doing the deep things on the 6000, T10 screws. Some are down deep. But I bought this. This is a ripper of a thing. I might have mentioned it before, maybe not. And yeah, 12 volts goes well. Haven't had to charge it yet. It's been used a fair bit. But I've got this other one. I got Chari her own drill because I gave her that lumpy bumpy Ozito thing that I rebuilt with a battery on it about that big. It's a bit heavy. So I got her. Which one is it? This one here. Yeah, the batteries clip on here. I mean, I got this and 2 batteries for $40 or something on eBay. It's a little bit brutal with the ratchet system. I wouldn't trust it. Maybe I've mentioned that before as well. And yeah, but that thing there, I've put extra big batteries in there, so it's damn heavy. So it works well, but it's not the best. But what happened is this. Have a look on the bench. If I can undo that and bend that down. The one of the batteries that came with it, basically 0 volts, and being 0 volts, the charger ignored it, and yeah, that's what happens with lithium batteries. If they get down in voltage, they will not accept the charge, and the charger won't turn on. And also, its battery protection systems will lock you out. You cannot charge the battery. So what I've done here, I've actually connected up my You'll Charge Everything device, which I got this years ago. This is so old, but it's the best battery charger I've ever got. It's basically automatic. It does everything. It does NiCads, nickel metal hydrides, lead acid, lithium polymer, and lithium ion. And you put 12 volts in it, it'll charge up to 21 volts, no problem. So it's got a switch mode in there. And yeah, it'll whack out a few amps as well. So at the moment, this one here, it's throttling down. It was charging an amp for ages, and now it's around about 0.28 of an amp and sitting at 20.5 volts. So there's 5 cells in here, 5 3.7. They are 3.7 or 3.8. Everyone says they're 4.2, but it's only a surface charge if you charge them up, and whatever. So yeah, anyway, I thought the batteries would be dead, and I just hit them with this. And actually, first of all, to even make sure this was going to turn, I just hit my supply on, and just current limited it and hit it with 20 volts. Just went tap, tap, tap on the terminals, and yeah, it started to draw a little bit of current. I said, okay then, so I stuck that charger on there. If it doesn't draw any current, that even this one here won't work. It'll just say open circuit battery or shorted battery. That'd be even worse. But it won't turn on. So just tapping it and giving it a bit of surface charge, that comes on. And as far as I can tell, all the cells didn't die a discharge death. What happens with these batteries, lithium batteries, This is why I always say, do not let your batteries go dead flat. Don't put them in a cupboard and forget about them. You'll come out, they won't charge. They'll be screwed. So what you want to do is keep them charged all the time. Every 3 months. They got a self-discharge rate of whatever, but probably every 3 months, just charge them up. And they'll last for years and years and years by doing that. So even on these, I should have something connects on the battery, and you put it away, and if it gets below a particular voltage, that this little other circuit starts going beep, 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 and annoys you until you go and charge it, because otherwise it's going to cost you a big handful of cash, especially with detector batteries. You want to go and one of the new detector. What's the battery worth? $300, something or other, or more. So you save yourself money just by monitoring. All you need is a low voltage detection circuit connected to the battery, plugs in, and when the battery gets down, say you probably don't want the cells to drop too far, and when it does drop too far, not that this thing's going to draw any current, it's because the high impedance thing, we don't care. But someone should make that. I should make it, shouldn't I? Because I talked about it. But if you made something that went on all the expensive batteries, and when you put them away and you weren't using them, and they had a little piezo beeper and a little, just coin cell, it wouldn't have to be much. Long life coin cell, you get a lithium one of those, God, things last 5 years easy. And it gets down, as soon as it cranks below a reference voltage set point, that it'll start beeping, and basically it's saying, charge me, put me on charge. So charge it and put the thing back on. So someone should do that, because a lot of batteries go in the bin because people don't charge them. But like even here, I'm not using this at the moment, but I've got that charging up because I haven't used it for ages. I said, I better get that and charge it. So I charge it, and I'm going to chuck it in the drawer and forget about it. No, I've got to use it for doing the sevens, because a lot of people don't send batteries. Some do, some don't. Depends how it's done, because there's a lot of funny postal regulations on that. Yeah. So anyway, that's why I haven't been making videos, because I've been too busy doing all these things down here and trying to develop up a really snazzy metal detector, just basically doing it as a project, and just see where we are. I've got people I can talk to on this too, which are quite expert in particular fields. See, digital is not my strong point. Analog is my background, and low frequency stuff is not my background either. It's all, microwave frequencies, gigahertz and above, where I used to do a lot of development work for satellite communication equipment. And if you go way, way, way back in time, I used to sit there fixing car radios for people. I'm glad I don't do that anymore. So, I was gonna actually write up a bit of a thing about the background in electronics from way back when to now. And I tell you what, it would be very interesting. I thought about it myself, and I thought it was interesting. Some of the companies I've worked for, some of the things I've done, some of the things I just couldn't get out of there quick enough. At one stage, I even had a whole heap of government contracts, and then the government went broke and wouldn't pay. That's another story. Sounds like a Labor government, doesn't it? Oh, I tell you what, I shouldn't say that. Someone's cotton onto those videos I put up about those lockout areas, and I think it's gone round a little bit. But anyway, so be it. Doesn't really affect me as such. I don't do any government contract work anymore. They would have kicked me out. But I could tell you some stories about the government and their employees. You probably already know. It's like this all the time. Unbelievable. What they call it, secret commissions. Jesus Christ. The whole industry was secret commissions. You didn't pay your secret commission, you didn't get any work. wasn't secret. It was out in the open. You know, bloody unbelievable. You know, and I'm not saying one or two. I'm saying all of them. There wasn't one I met that didn't put the hand out for something. And I tell you, um, that's 100% true. But like I say, this is back um, in the 1980s, and it's a long time ago. So I think they're all safe. The statute of limitations has expired. I don't know. But unbelievable. I can't remember the name of them now anyway. And all the departments have changed, and some of the people have just curled up their toes and died because some were pretty ancient back then. So, yeah, all good fun. Very much so. So, can we end up making a better metal detector? Of course, we can make a really good detector. Yeah. So, I'm not going to give, like I say, I don't want to give too much away. I just want to say that, you know, that's what I've been doing. It's like people go, "Oh, well, he hasn't made videos for ages. What's going on?" You know, has he kicked the bucket, or you know, locked up in the hospital, or locked up in the local clink or something? Who knows? But nothing untoward. We're just working away and trying to get things done. It's all good fun. Um, yeah. So yeah, that's probably it for the time being. I can't, you know, keep talking about the same thing because it's boring. I know that, but I'm just saying things are on the go, and yeah, we'll get there. By the way, that those waveforms I showed just then, I better explain something. I'll go around. Thank God the computer's turned off. You never know what's on the screen sometimes. But anyway, if you have a look at all that there, I don't even know if you can zoom in and look at it. That's the timings for the SD2000. I think running the master oscillator probably at 2 megahertz or something. I don't know. So you change the frequency, the time base, all those will change, but the whole thing's uh, like linear. So you know, you move one, the other moves, dead time moves, receive windows move, everything moves. You don't want that. You want to be able to adjust your receive times and dead times, basically. You know, depending on things like coil characteristics, ground die-off characteristics. Probably the main thing. Size and type of gold you're looking for. Yeah. So the thing is too, with all that there, you have a look at it. Like the top there, you can say, oh, look, there's you know, there's two lots of switching waveforms per channel. So you got 1, 2, and 3, and technically 4 channels, but one channel's earth field cancellation, and you could basically got your pulses for channel 1, channel 2, and then you got more in the realm of ground balance. So, but you can do all that serially now. Run it like a cut cat with a SAR ADC, and you basically going to get all those turned into numerical values, and they're all up for manipulation in the digital realm. So you can just assign things how you want. You can just make those pulses in, out. You can make them, you know, where there's a repetition of all the same sizes there, you can make them bigger and smaller and different windows, as long as you track it within, you know, a reasonable amount, and just move your ground balance in relation. Yeah, Earthfield's no really big deal. Just take a really big long sample at the end of everything where nothing really happens, and yeah, that's very simple, very simple indeed. That's not really rocket science, except it was rocket science when Garrett's detectors wouldn't work here in the late 1970s, and it was to do with the mix of our ground here. It's got maghemite in it, and had upset the stuff that was made for the American ground. Anyway, that's written on the internet somewhere. You can go and read all about that and the big story about it. And the word starts with B, and another word with S was used a lot when it was first mentioned. It was BS. uh, yep, someone had to fly over here and actually go on the ground, and they went, oh. So, yeah, funny stuff. Very funny stuff. Um, yeah, so, yeah, I'm just waffling on now, aren't I? I'm just doing the old waffle. But yeah, I know some of you guys um, like all this sort of stuff, about how it all works. That's why I don't have, you know, I don't know what 200,000 people subscribe to the channel, because there's not 200,000 smart people who want to know about metal detectors in the world. If you ask me, there's just a few. So 10,000 is probably it, or whatever it's at. I don't even know what it's at. But it's not made. This isn't made for total entertainment. It's made for a bit of education, bit of discussion. What goes on, and the average Joe Blow out there. That's very Australian. The average Joe Blow means the average person um, really do not care less about how things work. They'll watch people swinging around with the detector in the bush. It's like watching Tats Lotto numbers. Am I going to win? Sort of like that. But I'm guilty. I watch those shows, and after I've watched it, what I don't know, maybe five times, like not watching it any again, because it's exactly the same each time. You know, there's nothing new. There's no innovation. There's nothing like that. It's just walking around the bush and saying, "Oh, beep beep." Try a different detector or something, or try different coils and do some testing. I don't know. That would interest me, but aimlessly walking around the bush, swinging a detector, does not interest me in the slightest unless I'm doing it. So, yeah, I suppose horses for courses. What do you want to watch? But some of the stuff out there they do is entertaining. Um, if you ever want to be entertained, go on, search for Vogus, Victor Oscar GUS, Golf Uniform Sierra, Vogus. His name's Chris, but we go by Vogus. He does a lot of panning in creeks and stuff, right? But the guy's quite funny. He's he's quite humorous, and he does a lot of editing on his videos. Unlike me, he's copped the whole lot. If I broke out in a coughing fit, it wouldn't be edited out. You'd see it all. But have a look at his channel if you're interested in gold in creeks and whatever. And he's got a lot of good techniques, and it's quite entertaining sometimes. Yeah, he always cracking jokes and stuff. So it probably beats this. This is probably a little bit dry, you know, but it is the way it is. Apart from everything else in the gold industry, I've heard nothing from anybody. I've got no idea where people's new detectors are that are meant to be coming out. What's Nocta doing? They're meant to have two PIs coming out. Never heard another boo out of it. Maybe they can't do something and it's not going to come out. I don't know. I've heard that with other companies too. They're out there testing, and and then they discover it's got all these problems, and it goes back to the drawing board. It does happen quite a lot. So apart from that, it's all good fun. And if you've got any, if you muck around with detectors yourself on that, if you've got any ideas of what type of CPU or MPU, whatever you want to call it, processor I should be using or settle on, what look, I don't know every ADC out there. I've looked at some of the LT and analog ones, and basically the same. And some, what were they? ST. I've looked at a few different ones out there, but if you know of any others, that would be really good for doing a detector. Something. I'm mainly looking for as much bit resolution as I can get and relatively high speed. At least go for 500 kilobits per second. A million's better, 2 million's more, but usually the price goes up by that amount. Yeah, more is more. But if you know of anything out there that's really good and cheap, leave it in the comments because I'll investigate it. You might have a contribution to something. But yeah, basically, the fast year ADCs we can run multi-channel ADCs. We run dedicated chips. We can have 2, 3, 4, 5, all doing a whole heap of different things on the serial streams and get massive resolution on every aspect if we want. But the price starts going up. If I had an unlimited budget for a metal detector and I said, well, the detector's going to end up costing $25,000 or something. God, you can make a bloody good detector, a lot better than what's out there, by a long shot. But like I was saying, you're going to go and spend $784 on an ADC, and you're going to put 4 of them in there. It's 4 parts. It can get very expensive. You've got to come up with other ways of doing things. And I'm sort of like, I don't like compromising. I like doing everything, get the most out of it and get the performance. But yeah, I don't know. If you're going to do this thing, it's probably going to get mass produced and marketed. And what will the market bear? I don't want to run out there and say, oh, it's a fantastic detector. It's going to cost you, go mortgage your house and you can have one. That's ridiculous. You're meant to make money. Well, I suppose you'd find more gold and make money, but it depends how you look at it. Some people, I don't know, they're like a negative to gold. They come along with their detector and the gold runs away and buries itself deeper like it's alive and they never find any. But it's all out there. You can find it. Even I find it, even if I'm really not particularly looking for it, it pops up. It's all to do that. I'm running super sensitivity and very, very quick on the in detection on the transmit pulse as much as possible. Try and get rid of all the noise out of the system, and then these things pop up, and you go, "Oh, beauty!" Another one, another 5 cents worth of gold. Because they're less than pinheads. They're tiny. It's stupid. I don't want to do that. That's when I don't think I'll go to that sparrow ground anymore over there because it's yeah, the gold is very, very, very tiny. But I did find a 20 ouncer over there, so maybe I just listen to big signals. Maybe I extend the pulse width out so I don't listen to anything small anymore and just go for big stuff at depth with a big coil because I know there's big gold over there. It's but it's probably all out of reach. It's 15 feet down in some places and 40 in others. So I'm not going to be able to detect stuff on the bedrock at 40 feet down, am I? Well, basically, it's a decayed layer down there, and it's just sitting on the top. Get rid of the clay, and no, I'm not going to go into that because the next time I go to Sparrow Ground, someone's going to have an excavator in there digging it up. Wouldn't surprise me. Things that's happened. You make mention of something, and next minute, it's bloody pothole central. It's just it's the gold. It's the gold. It does things to people. Anyway, nearly 5 o'clock, and I'm expecting David to come round with more detectors. So he hasn't come round. Usually, because he usually comes to you. I've got stuff that's got to go to him, then it's got to go to the post office and get sent back to the customers. So, yeah, I don't know. Maybe he's not going to come round today. I might be able to breathe and have a rest. But no, I've still got other detectors to do. So I'll still be working here for a while yet. Anyway, like I said, see, that's what happened. Turned into a waffle. Anyway, catch us.